Take a piece of paper, any paper, something so ordinary it is invisible to you. Now tell me, how many times could you fold it in half before it stops you completely? How many times before the paper beats you and you give up? Most people guess 10, maybe 12. Some confident people say 20. They are spectacularly wrong. The real limit, folding by hand, is closer to 7 or 8. But that is not the interesting part. The interesting part is what happens when you keep going mathematically, because there is a specific number of folds, a number so large it sounds like science fiction. That takes that same sheet of paper beyond the outer edge of the observable universe, beyond every star, every galaxy, every corner of everything we have ever seen or measured. The entire observable universe, exceeded by a piece of paper. I will tell you that exact number before this video ends. Most people will not make it to that number. The ones who do will never look at something small the same way again. Stay to the final minute and become one of them. In the next 12 minutes, we are going to fold paper to the moon, past the sun, through entire galaxies, and right to the edge of everything that exists. Fold by fold, the answer to how many times you can fold a paper in half is insane. And it will change how you see every small decision in your life. Here is a challenge I want you to try right now. Grab any standard piece of paper, fold it in half, fold it again, and again. Keep going. What happens around fold 6 or 7, it becomes almost impossible. The paper resists you like something alive. Your fingers lose leverage. The stack becomes stiff, rigid, almost hostile. Most people max out at 7, maybe 8 folds, and they assume that with bigger paper or more strength or a thinner sheet, you could push much further. That intuition feels right. It is also completely wrong. When you fold paper in half, you are not just doubling the thickness. You are doubling the thickness and having the available length to fold. Every single fold simultaneously makes the stack taller and the remaining paper shorter. By fold 7, you have 128 layers compressed into a tiny rectangle. The paper does not get weaker. You simply run out of paper to fold. The bending rigidity of the stack grows so fast that by fold 8, the stack is structurally comparable to thick cardboard in terms of the force required to crease it. By fold 10, theoretically, it would behave closer to wood. 128 layers, fold 7. But here is the disturbing truth. What happens to that number? 128 layers. If we just keep going in mathematics with no physical paper at all, the answer makes fold 7 look like a warm-up. And the next discovery made the entire world rethink what paper folding actually means. Stop here for a second, because this next story changed everything we thought we knew about paper folding. In 2002, a 16-year-old high school student named Brittany Gallivan was given an extra credit challenge. Fold a piece of paper in half 12 times. Her teacher assumed it was impossible, a thought experiment to illustrate limits. Brittany assumed it was a puzzle worth solving. She did not just fold paper 12 times. She derived the mathematical formula that makes it theoretically possible to fold paper any number of times, given the right dimensions. Her formula, now known as the Gallivan paper folding equation, accounts for the relationship between paper thickness, paper length, and the number of desired folds. It is referenced in mathematics and engineering education today. A 16-year-old cracked a problem that every adult dismissed as impossible. She used gold leaf tissue paper, incredibly thin, stretched to over 200 meters long, and she folded it 12 times in a shopping mall on the floor, surrounded by classmates. The resulting stack reached over 75 centimeters tall. If this story is blowing your mind as much as it should, hit like and subscribe, because what the math reveals next will break your brain completely. Seriously, you are not ready for where this goes. What Brittany proved was that the limit is not impossible. It is geometric. And geometry, compounded over and over again, becomes something almost violent in scale. The next step is where that violence truly begins. Now, what I am about to show you seems incredibly simple, but it is the single most important mathematical principle behind everything you are about to hear. Pay close attention. Every time you fold a piece of paper in half, you double its thickness. That is the entire engine driving everything. Not add, not multiply by 10. Double every single time. A standard piece of paper is approximately 0.1 millimeters thick. After one fold, 0.2 millimeters. After 10 folds, roughly 10 centimeters. About the thickness of a paperback book. Still manageable, still imaginable. This is where your brain is about to betray you completely. After 20 folds, over 100 meters tall, taller than a 30-story building. After 27 folds, taller than Mount Everest. After 30 folds, over 100 kilometers, past the edge of Earth's atmosphere. Your brain protests here. It says these numbers cannot be right, but they are, because doubling does not grow in a straight line. It explodes upward on a curve that accelerates faster than anything we intuitively understand. The physicist Albert Bartlett spent his entire career trying to teach this lesson. He said it more clearly than anyone else has managed to. The greatest shortcoming of the human race is our inability to understand the exponential function. He was right. The numbers you are about to hear will feel impossible. They are not. They are simply math doing what math does. And the next destination, the first truly mind-breaking one, is one most people never forget once they hear it. Now forget everything about physical limits. We are doing pure mathematics, and pure mathematics has absolutely no mercy. Fold 42. This is the number for the moon. Fold 42. A standard piece of paper, folded in half 42 times, creates a stack approximately 440,000 kilometers tall. The moon is roughly 384,000 kilometers away from Earth. Your piece of paper, the one from your desk, the one you scribble notes on, would exceed the distance to the moon with room to spare. Let that land for a moment. A piece of paper, the moon, 42 folds. This is not a trick or an approximation. It is basic arithmetic. 0.1 millimeters multiplied by 2 raised to the power of 42 equals 439,804 kilometers. Verifiable with a calculator in under 30 seconds. NASA Apollo 11 took 3 days to travel 384,000 kilometers to the moon. 3 days burning rocket fuel at thousands of kilometers per hour. Your paper gets there in 42 doubling steps. And here is where most people close the mental door. They say, I get it, exponential growth is powerful, I've heard the moon fact. They close the door too early. Because if fold 42 reaches the moon, what does fold 50 reach? What does fold 60 reach? The answer does not just surprise you. It starts to feel like either the universe is much smaller than you thought, or your piece of paper is far more dangerous than you imagined. Let me pause here, because this is where the numbers start making emotional sense and start making something closer to dread. Fold 51 takes your paper past the distance to the sun, not toward it, past it. 150 million kilometers of space, exceeded at fold 51. Fold 60, you have passed the orbit of Pluto, beyond the classical edge of our solar system. Past Pluto, fold 60, that is nearly 6 trillion kilometers. The Voyager 1 spacecraft, launched in 1977, currently the most distant human-made object in existence, took over 35 years of constant travel to reach that distance. Your paper gets there at fold 60. 35 years of space travel. 60 folds of a piece of paper. Now here is where most people make the critical mistake. They hear fold 42 equals the moon, fold 60 equals Pluto, and they think they understand the scale. They do not even close. Because after fold 60, the numbers do not just keep growing. They start growing faster relative to everything that came before. Each fold after 60 adds more distance than all of the previous 60 folds combined. That is what exponential means at sustained scale. The acceleration accelerates. Carl Sagan captured the spirit of this beautifully when he wrote, "The cosmos is within us. We are made of star stuff. We are a way for the universe to know itself." Your piece of paper is about to know the entire cosmos and where we are going next. The numbers leave the solar system entirely and enter a scale where even professional astronomers run out of familiar landmarks. Here is where the story takes a dark turn. After fold 78, your paper stack stretches for 24 light years, the exact distance to Proxima Centauri, the nearest star to our sun. You have left the solar system entirely. You are traveling between stars now, with a piece of paper. After fold 83, you have crossed the full diameter of the Milky Way, our galaxy, 100,000 light-years across, containing an estimated 400 billion stars, exceeded at fold 83. 400 billion stars, 83 folds of a piece of paper. Fold 90 takes you 10 million light-years into space, past the local group of galaxies, the cluster of approximately 54 galaxies that includes the Milky Way and Andromeda. You have moved beyond our home neighborhood of the cosmos entirely. Fold 100 takes you 100 million light-years into the cosmic web, the vast filamentary structure of galaxy clusters and dark voids that gives the universe its large-scale architecture. Take a moment with that. Fold 100, 100 doublings of something a tenth of a millimeter thick, and we still have not reached the number I promised you at the beginning of this video. The specific number that was waiting there from the first second. We are 3 folds away from it. But before I reveal it, there is something you need to understand about your own brain. Something that explains why, even after hearing all of these numbers, you still cannot truly feel the scale. And that misunderstanding is not just academic. It is one of the most dangerous cognitive blind spots that human beings carry through their entire lives. You have been hearing these numbers: the Moon, Pluto, the Milky Way, and your brain has been accepting them intellectually, filing them as facts. But there is a gap between understanding a number and actually feeling its scale. And that gap is not a personal failing. It is a feature of human biology that may have already cost you more than you realize. The human brain evolved for linear thinking. We track footprints. We count arrows. We estimate distances to water sources. We are exquisitely calibrated for addition, for moving forward by 1 unit at a time. But exponential growth, where something doubles and those doubles double and those doubles double again, is simply not what we evolved to feel in our gut. We understand it intellectually. We cannot feel it. That gap is dangerous. There is an ancient story about the inventor of chess. A king was so delighted with the game that he offered the inventor any reward. The inventor asked only for rice: 1 grain on the first square, 2 on the second, 4 on the third, doubling across all 64 squares of the board. The king laughed. It was just a chessboard. He would give the man his rice. He could not. The total was 18 quintillion grains of rice. 18 quintillion grains. More rice than has ever been grown in all of human history combined. The king was not stupid. He understood the rules perfectly. He simply could not feel what doubling 64 times produces. Your brain, the same architecture, is walking around today completely blind to the exponential forces already shaping your life. And the next examples will show you exactly how real and how costly that blind spot already is. Here is what nobody tells you about exponential growth. It is not just mathematics on a page. It is alive in your world right now, moving through systems you interact with every single day, and it never announces itself until it is far too late. A single bacterium divides once every 20 minutes. After 1 hour, 8 bacteria. After 12 hours, over 68 billion bacteria from that single original cell. In December of 2019, there was a cluster of pneumonia cases in one city. The initial numbers were small, invisible almost. By March 2020, that same exponential curve had reshaped the entire planet. Exponential growth looks completely manageable right up until the exact moment it does not. Exponential growth looks like nothing until it looks like everything. Compound interest follows the identical mathematical logic as your paper. That is why a modest, consistent investment held for decades becomes something almost unrecognizable in size. The same doubling principle applied to money over time. Einstein, in a quote that captures something profoundly true regardless of whether he actually said it, is credited with: "Compound interest is the 8th wonder of the world. He who understands it earns it. He who doesn't pays it." Nuclear chain reactions, viral information spread, technological capability. Every system where doubling can occur without friction follows the same curve as your piece of paper. Same curve, same terror. And the next segment, this is the number I promised you at the very first second of this video. The specific number that started this whole journey. You have been building toward this moment. Do not stop now. Here it is, the number from the very beginning of this video. The answer I promised you. Fold 103. Fold 103. At 103 folds, a standard 0. 1 millimeter piece of paper produces a stack approximately 93 billion light-years tall, the diameter of the observable universe. Every photon of light that has ever reached us, every galaxy we have catalogued, every corner of space the Hubble Space Telescope has ever photographed, every object science has ever detected, is approximately 93 billion light-years across. A piece of paper, 103 folds, the entire observable universe, exceeded. Let me say that again for your brain to attempt to process. 103 doublings of something 0. 1 millimeters thick equals the diameter of everything we have ever seen or measured in the cosmos. 93 billion light-years, 103 folds, a piece of paper. And here is the detail that makes this even more profound. You cannot physically do it. You could not fold a real piece of paper 103 times, even with unlimited strength, and a sheet the size of a continent. By around fold 80 to 90, the individual layers become thinner than atoms. You would need to be working with structures smaller than a single proton. Physical matter itself would stop you long before you reached 103. Thinner than atoms, fold 90. The mathematics exists. The physical paper does not, and that gap between what numbers can describe and what physical reality permits is one of the most profound statements in all of science. If this has genuinely shattered your sense of scale, I want to know. Comment universe exceeded if this broke your brain, or just math if you saw it coming. I will pin the best responses. And if you know someone who thinks they understand how large the universe really is, share this with them. Share it with as many people as you possibly can. This truth about exponential growth deserves to reach everyone. Here is what I want you to take away from all of this, and it is not about paper. The paper folding problem was never really about paper. It was a mirror held up to something much more personal. The most powerful forces in the universe do not announce themselves. They compound in silence. Every time you dismiss something because it seems small, a small habit, a small investment, a small daily choice to keep going rather than stop, you are making the same mistake the king made with the chessboard. You are looking at fold 1 and deciding it does not matter. You cannot feel what fold 42 becomes, what fold 103 becomes. Small things, doubled consistently, become the entire universe. Archimedes understood this about leverage long before the mathematics of exponential growth was formalized. He said, "Give me a lever long enough and a fulcrum on which to place it, and I shall move the world." He was describing the same principle. Small input, correctly positioned and consistently applied, produces unlimited output. That is exponential. That is the paper. You are the paper. Every choice you make is a fold. Every habit, every investment, every decision to keep going or to quit, it is a fold, and folds compound. You are the paper. Most people stop at fold 7. They feel the resistance and assume they have reached the wall. Brittany Gallivan proved that the limit is not a wall, it is a formula. Change your conditions, adjust your approach, and you keep going, all the way to the moon, all the way to the edge of everything. If you made it to the end, prove it. Comment fold 103 right now. I want to see who reached the edge of the universe today. The truth is stranger than anything you could make up. Subscribe if you want to keep discovering it. A piece of paper, 103 folds, the entire observable universe. We started with something that fits in your hand and ended at the outer edge of everything that exists. Everything you know. And the number that took us there was not a billion, not a trillion. It was 103. 103 decisions to keep doubling. That is the lesson this paper teaches about scale and about life. The universe rewards those who refuse to stop folding. 42 folds to the moon, 103 to the edge of everything. What are you waiting for? Comment fold 103 right now if you made it here. I want to see every single one of you. The truth is stranger than anything you could make up. Subscribe to keep discovering it.